Okay, we're going to be looking at some review questions about linear relations and functions to get you ready for your quiz. So number one, we've got these two diagrams, f of x and g of x, and we want to state the domain and range of each of these functions. So the domain is like all of the x values, and one way you can do this is by kind of imagining, all of these, if we're smushing the graph down to the x-axis, we see that we've ended up covering absolutely everything along the x-axis, and this goes on forever in each direction, so we're going to end up covering the x-axis forever in each direction, and so our domain of f is going to be that x is all real numbers. However, if we smush it against the y-axis, we'll see that it's only going to go up from 2, and then it will only cover the y-axis above 2. And so our range of f is going to be that y is greater than or equal to positive 2, because those are the only values on the y-axis that correspond to y values on my function. In part B, function g, so we're going to find the domain of function g. So that's again all the x values, so let's smush it up to the x-axis, and we see that what we've covered is everything from negative 360 degrees to positive 360 degrees. And so these are going to be my values of x, everything in between those two. And our range of g, let's smush it now against the y-axis. And so these all come to this area, and these all come to this area. And we'll see then that what we've ended up covering is everything along the y-axis from negative 1.5, and these are the y's, aren't they, up to positive 1.5. And so those are your domains and ranges of functions f and g. Number 2. The equation of the line is 2x plus y minus 8 equals 0. And the line R2 is perpendicular to this first line, R1. Now we know that perpendicular lines have got slopes that are negative reciprocals, so perhaps we should start by writing R1 in slope-intercept form, which means that we have to get y alone on the left. So our positive 2x will move to the right and become a negative 2x, and the negative 8 will move to the right and become a positive 8. And now we can see that our slope of line R1 is equal to negative 2. We're trying to find the gradient or the slope of R2, which is perpendicular. So let's find the perpendicular, the negative reciprocal, and the slope of R2 then is going to be the negative reciprocal. This was negative, it's now positive, and the reciprocal 1/2. Part B. We've been told that the point of intersection of the two lines is 4, k. We need to find the value of k. Well, look, if this is a point of intersection, we know that it must exist on both of the lines at the same time. So let's substitute this point then into R1, because we know it must exist on line R1. And so our x value is 4, our y value is k. And let's solve this equation then. 8 plus k minus 8 equals 0. The plus 8 and the negative 8 cancel, and we find that k is equal to 0. And part I, what is the equation of line R2? Well, we now know that because k is 0, that we're going through the point 4, 0. So we've got our slope of 1/2. We've just got to figure out what our b value is. And because we know this point, 4, 0, which exists on both of the lines, because k was 0, let's substitute that in. Our 0 for y, and our x is 4. And then we'll figure out, this is half of 4. Half of 4 equals 2. Let's bring it to the left, and we discover that b is equal to negative 2. And therefore, the equation that we're looking for is 1/2 x minus 2 is our b value. Number 3. So we've got the coordinates of the vertices of a triangle. We need to calculate first the gradient of the line AB. We know that the gradient is the difference in the y-coordinates over the difference in the x-coordinates. Just make sure you preserve the same order. equals 6 over negative 3, which is negative 2. So that's the gradient of AB. They've given us that the line AC is perpendicular to the line AB, which of course means that its slope is the negative reciprocal. And so this perpendicular slope then will be positive, because the other one was negative, positive, and the reciprocal 1/2. And we need to find the value of P, which is this third point. That is the y-coordinate of that point. And so if we've got, we know that our slope between A and C, right? This was the slope AC, the perpendicular one. We know that its slope is 1/2. And so that slope must be equal to the change in y between A and C divided by the change in x, which is 4 minus 0.5. And so let's just simplify this a little bit. This means that 1/2 equals 3 minus p over 3.5, and we'll cross multiply. So 3.5 times 1 is 3.5. 2 times 3 is 6, and 2 times negative p is negative 2p. And so now we can solve for p. If we bring the 6 to the other side of the equation, it becomes a minus 6. So 3.5 minus 6 equals negative 2p. And this gives us negative 2.5 equals negative 2p. And if you do negative 2.5 divided by negative 2, you're going to end up getting 1.25. You can do that on the calculator, but p equals positive 1.25. Number 4. The straight line has got this equation, negative 1/2 x minus 2. What's the y-intercept? Well, we can see the y-intercept right there. Oops, I don't know why, that was weird. I can't explain why that just happened, so let's try that again. There's our y-intercept, and so we can call it b if we like, negative 2. What is the gradient of L1? Well, we can see that right here. M is equal to negative 1/2. Part C. Given that line L2 is perpendicular and passes through this point, first they want the gradient. Well, once again, we know that perpendicular lines have got slopes that are negative reciprocals. And so the negative reciprocal of negative 1/2 will be positive 2 over 1, which is just like saying positive 2. And part D, the equation of line 2, well, let's see, we know what the point is, 3, 7, and we know what the slope is, positive 2. So let's start with a slope-intercept form. If our slope is 2, y equals 2x plus b, we can substitute in the point 3, 7. There it is, and we'll quickly be able to figure out that b is equal to 1, and therefore our equation must be y equals 2x plus 1. However, we need to leave it in the form where the x and the y terms are together on the left-hand side. So let's bring the 2x over to the left. Becomes a negative 2x. We still have that 1y on the left. We also have to bring the positive 1 to the left. Becomes a negative 1. And there we go. There's our final equation. Number 5. On the grid, we're supposed to draw a straight line with a gradient of negative 3 that passes through the point negative 2, 0. Well, there's negative 2, 0. For it to have a gradient of negative 3, we know that the line's falling, and it will be falling by 3 units every time that we move forward 1 unit. It will fall by 3 units every time we move forward by 1 unit. That's a rise of negative 3 over a run of 1. And you can quickly see that the line that's forming looks kind of like that. So there's a sketch of the line. Part B, we need to find the equation of the line. Well, we can see that it goes through a y-intercept of negative 6, and we've already figured out that the gradient, or we were told that the gradient is negative 3, and so our equation then, y equals mx plus b, let's substitute, our slope is negative 3, and our y-intercept is negative 6. Number 6. Alright, we've been given the equation of the line. We need to find its gradient. Let's put it into slope-intercept form so we can see its slope. That means putting y by itself on the left, so we have the form y equals mx plus b. So 4y is equal to negative x plus 34. Let's now divide through by 4, and so this x is now only a quarter x, or negative a quarter x, and the 34 is also being divided by 4. I divided the whole thing through by 4. And we can see then that the gradient is equal to negative 1/4. Alright, tells us that the equation of line 2 is y equals mx, and so we can see that its slope is something called m. And if the line 2 is perpendicular to line 1, well, that must mean that this line 2 slope is the negative reciprocal of the line 1 slope that we already found. And so that m is going to be equal to positive the reciprocal 4 over 1, which is just equal to 4. And lastly, part C, let's find the coordinates of the point of intersection between line 1 and line 2. And so we've got, let's see, we've got our first line, which we've got its equation here. So that's y equals negative a quarter x plus, I can simplify this a little bit to 17 over 2. And I've also got another line, y equals mx, and we figured out that our slope is 4. So let's put these into our graph, and so y1 will be negative 0.25x plus 17 over 2, which is 8.5, and our other equation 4x. And let's see where they intersect. There's the first line, and there's the second line. In order to find that point of intersection, we'll go second, calculate, option 5. Yes, that is our first curve, enter. Yes, y24x, that's our second curve. And we'll guess, looks to me like they intersect at an x value of approximately 2. Let's see how close I was. Yes, that's in fact exactly right. That x is equal to 2, and the y value at the coordinates of that intersection is 8. Number 7. Gradients of several lines, we can see them. We need to find two pairs of lines that are parallel to each other. We know that parallel lines means that the slopes are equal. So let's find two slopes that are equal to one another. Looking through, you'll notice that this one, negative 5 over 2, is equal to negative 2.5. And that this one right here is also equal to negative 2.5. So one example of two lines that are parallel to each other are B and G. I'm just looking to see if there's any other pair of lines that are parallel. I can't see any, so I think that's it. We're also in part B supposed to find two pairs of lines that are at right angles to one another, meaning they are perpendicular. And if they're perpendicular, then they are negative reciprocals. And I can see that A and C are negative reciprocals of one another. I've also, in fact, got another example of two that are... I just found another set in part A. Look, 0.5 and 3 over 6, those both equal 1/2, don't they? So another solution to part A would have been lines D and E. And I can also see that 0.4, if we wrote this as a fraction, it would be 2 over 5. That's the negative reciprocal of G. So we could say that G and H is another example of a pair of lines that are perpendicular because they're negative reciprocals. Or you could even say B and H would be another pair that are perpendicular because they are negative reciprocals of one another.